In this first example, we're asked to find the missing values that make each statement true. For part A, on the left-hand side, we have two logs with the same base, and we're adding those logs together. On the right-hand side, we have log base 5 of some value. One of the things that you can try to do with these different types of problems is apply the laws of exponents, or of logarithms, which really are the same as the exponents. So we have the same base, we're adding these logs. What we want to do is we want to multiply the 11 and the 9. So this is log base 5 of 11 times 9 is equal to log base 5 of some value. If we do the multiplication, 11 times 9 is 99, and that's equal to log base 5 of some value. It's only at this point where it's okay to drop the logs and the bases. We don't really get rid of them. All we're doing is we're saying that if we have logarithm of base 5 or any base equal to the logarithm of 5 or the same base as the other side, and this position is the one we want to know, these have to be equal. So the thing that goes in the box is definitely 99. You don't want to do this type of procedure here in this step before. If you try to do that, you're going to get something like 11 plus 9, and you'd get 20. That answer would be definitely wrong. You need to apply those logarithm rules first, and then once you have a log with the same base on each side, then you're allowed to say that those argument positions are equal. With the one on the right-hand side, part B, we have a similar setup. We have log base 7 of 5 minus log base 7 of some value equal to this logarithm on the right-hand side, and the bases are all the same. Let's try to combine these, or we could even expand this one, but let's try to combine these first. So if we combine these, that's log base 7 of 5 divided by the number that goes in the box. Remember that when we're subtracting logarithms, we're allowed to combine those if they're the same base, and then we're going to take this left position that's going to go in the numerator, and the right position will go in the denominator. This is equal to the log base 7 of 5 over 3. If you want to add parentheses, you can. If you look at these two values, then we have log base 7 on each side, and then we have 5 over 3. So this box part must be 3. That's the missing value. Alternatively, what you could do is split this logarithm up. So this log would be log base 7 of 5, the numerator stays here, minus log base 7 of 3. And then you can equate that to this statement on the left-hand side. The log base 7 of 5 are the same, and this minus log base 7 of 3. So you get the same answer. With this, with part C, we have something to do with this 3 hanging out outside. So we're going to use the power rule in this case when we have this number that's just on the left-hand side. It's got to be multiplied by the log. And what we're going to do is we're going to take that, and this is the power rule, we're going to move it to the exponent position right here, and that's equal to log base 7 of some value. If we do a little bit of math, this is all inside parentheses here. It's the argument position of the log. 3 to the third power is 3 times 3 times 3, so that should be 27. We've got log base 7 of that value. And it's only at this step that we can say that 27 is the missing spot. So we can write 27. With this one on the right-hand side, we have to figure out this value that goes out here. So we want to look at the right-hand side and see if we can change this 216 into some power. If we can, then we can go ahead and move that out like a base and an exponent. The base has to be 6. So in our mind, we're asking ourselves, 6 to what power is 216? This is just an intermediate step here. 6 to the third power would be 216, or 6 times 6, which is 36, times 6 is 216. So we can change the right-hand side to look just like this. Log base 9 of 6 to the third power, and again, that's all in that argument position. We can now take this 3, move it out front, so we'll have some number times log base 9 of 6 is equal to 3 by our power rule, log base 9 of 6. 3 and 3 are in the same position. There's only one logarithm on each side, so at this point we can definitely say that this box needs to be 3.